All right, guys, this is off practice exam number 1, at least as we took in the year 2023. Problem number 2 on free response right here. They give you this really weird-looking graph here of this equation right there, which is pretty obviously an implicitly defined equation. And as we can tell from the graph, this thing is not a function of x because it very clearly fails the vertical line test. It's also not a function of y because it fails the horizontal line test. So you just have this random equation right here given to us by that equation, and they tell you the known derivative of this equation is right here. Now something interesting happens next. They tell you in this sentence right here that the coordinate of point P located right here, the x-coordinate of point P is 2. So we know that this thing is right here. And what we're supposed to do for starters in part A is to write an equation for the line tangent to the graph at point P. Okay, here's where this got interesting. What a lot of us did when we looked at this problem is we said, okay, I can tell here that the x-coordinate of point P is 2, plus they told us that, and I'm just going to infer right over here that the y-coordinate of that point is 5. So a lot of people said that the coordinates of point P were 2, 5. And I certainly can see why you would think that, but I would wonder why right here they went out of their way to tell us that the x-coordinate was 2, but they didn't tell us that the y-coordinate was 5. So the first thing I would do would be to find out if that point actually works in this equation that was given right here. It feels like a trap. So let's see. Our x-coordinate is 2, so 2 squared is going to be 4, and that should equal now negative 2 plus a y-coordinate that we believe to be 5, and then plus a 5 times the cosine of your y value, which is 5 as well. And right now I have a really bad feeling about this, guys. Cosine of 5 radians? 5 is not a nice clean number to evaluate cosine at, like pi or pi over 3 or 7 pi over 6, something like that. I've got a feeling that the cosine of 5 is an ugly, irrational number. And when I multiply that by 5, it's still going to be ugly and irrational. I don't think this is going to work. Now, more to the point here, what am I getting at right here? The negative 2 plus the 5, I'm going to kind of work up on this, guys. 4 would equal then a 3 plus 5 cosine of 5. We would subtract a 3 from both sides and get 1 is equal to 5 cosine of 5. And then divide by 5, 1/5 is equal to the cosine of 5? I really don't think that's right there, guys. So this one doesn't work out, and I'm going to not waste any more time with that little venture right there. Let's go ahead and let's solve for y here, which, because I think the answer is going to be irrational, we're probably going to need our calculator in order to do that. So we're not going to assume that the y-coordinate here is 5. We'll leave that blank for right now and solve for y. But we do know the x-coordinate is 2. So 4 was right there, and it equals negative 2 plus y plus 5 times the cosine of y. And at this point right here, guys, I don't think there's any point trying to do this by hand. I am going to go to my calculator now and let it solve that equation for me. So for you guys, it's menu 31, and we're going to solve this equation right here. So our left side became 4, and that is equal to, we have a negative 2 plus a y. Ooh, my y is hiding under my x, I believe. There it is. So a negative 2, gotcha, plus y. And then, it was a plus 5 cosine of y. So 5 times the cosine of y. Gotcha. Let me close that angle off. That's our equation, comma, which is right there, and we want to solve that equation for y. And when I hit enter, I'm going to go ahead and look for that one as a decimal. These are the answers that we came up with right here. Now, we thought that our y value was relatively close to 5, so the answer I've got that it sounds the best to me is this first number here of 4.928. I suppose what I could have done is gone back to that equation right there, and instead of just saying solve it generically for y, give me the solution closest to y equals 5, and there's the answer. So 4.928 is what we get for y there. 4.928. So what we now know, everybody, remember we're trying to find the equation of a tangent line, is that our point of tangency is the ordered pair 2 and then 4.928. We also need the slope of the tangent, and that comes from our derivative here. So dy dx evaluated at point P, everybody, is going to be 2 times x. And remember, x is 2 at that point of tangency. So that's, I'll just go ahead and write that out. That's going to be a 2 times a 2. And then in the denominator, 1 minus 5 times the sine of that number, 4.928. So let's put that in the calculator and see what that gets us. What I am going to do here real quick, guys, and you'll see why in just a second, I'm going to hit my up arrow. I thought I was going to hit my up arrow. Okay, down, and I'm going to hit enter. And now what I'm going to do is just go back a few spaces and get rid of the y equals right there, and then just hit enter. Now here's why. What I want to do now is evaluate that derivative, which was 2 times 2 in the numerator. And then in the denominator here, it was 1 minus 5 times the sine. And now for my y value, I can just hit last answer. And that'll get me that number pretty darn precisely right there. that'd be 680 if we rounded that to 3 places. So 0.680, and that right there is the slope of our tangent. So now that we know the point of tangency and the slope of the tangent, we can go ahead now and write an equation for the line tangent to that graph. Now, almost all year long, I've been telling you guys to write these equations in point-slope form, which would have begun y minus that number right there. But I'm going to go ahead and do what they do a lot, which is write it in something called point-slope equation. So hold that thought of y minus the 4.928, and I'm going to make this y equals. Now, in point-slope form, the slope would come next, 0.680 times in parentheses x minus your x-coordinate, which is 2. And right here, guys, when we would have taken y minus 4.928, now I'm just going to add that number, 4.928, over there on the right side. And that, everybody, is the equation of our tangent line written in a form called point-slope equation. Now again, the directions didn't specify what way or what manner you had to write it in, so anything would be fine right there. Point-slope form, slope-intercept form, or point-slope equation, but this is maybe the fastest and easiest way to get that thing solved for y. Okay, so that was part A. And real quickly, if I were to just eyeball here what I think that slope is right there, it kind of looks like that. And my question for you guys, does it look like that slope could be 0.680, which is roughly about 2/3? Yeah, it feels decent with that one right there. Yeah, we'll run with something like that. All right, let's take a look at B. Now, this problem was just mean on their part. I don't know that anybody in any test that I graded got this one completely right. Even those of you who really knew what you were doing, you fell for a mean little trick that they played and you missed 1 point right here. Let me show you what I mean. So we're supposed to find for y less than or equal to 11, which really was the range of this entire equation right here. We're supposed to find the y coordinate of each point on the graph where the line tangent to the graph at that point is vertical. Okay, so the slope of a tangent, everybody, comes from your derivative. And the derivative in this problem, dy dx, was given to us as a 2x over a 1 minus 5 sine of y. We want this quantity right here. Let's think about that, guys. If we want our tangent to be vertical, running this way, that means that our slope needs to be undefined. So we want this derivative to be undefined. This is odd. This is not usually something they want us to find, but that's what they're asking for in this problem. So ask yourself, when is a fractional expression ever undefined? That only happens when your denominator is equal to 0. So we're going to take 1 minus 5 sine y and set that denominator equal to 0. And we'll solve for y, and that'll tell us everywhere that our derivative would be undefined, which means our tangent line would be vertical. So what a decent number of you guys did is you said, all right, I'm going to go to the calculator to solve that as well. So one more time, guys, menu 31 for you all. So we would solve, and our denominator right here is 1 minus 5 times the sine of y. Gotcha. Let me close off that angle right there. And we want to know where that denominator is equal to 0, comma, and let's solve that for y. And again, I would hit Control-Enter right here. Oops, not that. Sorry about that. To get decimal answers right here. And we came up with this mess right over here, and I wasn't thrilled about this. The problem here, guys, is those ends kind of suggest that there might be a whole bunch of answers out there, and it kind of looks like, yeah, I mean, the end implies that there could be infinitely many. So I'm a little concerned that there's more than just one. So what we're going to do now is another way of solving this equation right here. I am going to add a page to my calculator right here, and we're going to add a graph, and we're going to type in this equation right here. 1 minus 5 times the sign. Now, guys, when we're graphing, everything needs to be done in terms of x. So I'm going to hit Enter right there. And now what I'm going to do is change my viewing window. If you go back to this problem, we only wanted to know y values here, everybody, that were less than or equal to 11. And let's go back to the graph itself. It doesn't look like this thing exists anywhere below y equals -1. So we're really just looking at a range right here from -1, less than or equal to y, which is less than or equal to 11. Now on my calculator, I replaced my y with an x. That means I need to change the x window here. So I'm going to go to Tools and go to Window and Zoom and Window Settings. And my x minimum, which of course is really the y minimum in this problem, I'm going to make that -2 just to give me a little bit of breathing room. And for an x maximum, instead of 11, for my y max, I'm going to put a 12 right there. And that really should be good enough, guys. So let me hit OK. And that now shows me, I'm looking for spots now where this function is equal to 0. Those would be our x-intercepts. And it looks like we've got 1, 2, 3, 4 of those in this window right over here. So this got to be a little bit of a pain, but we had to write all of those out. So I tell you what I'm going to do. This is something the CAS will do very nicely, guys. When you do a graph trace, all right, so tools right there, and then trace, and then graph trace, the CAS will usually tell you when you have an intercept at a particular point. Oh, that was weird. All right, why did you get here? All right, let me keep going to the left with this, guys, and I'm hoping it'll tell me, come on, when I hit an, okay, fine, when I hit an intercept, and let's see, okay. I think we've got one right here, guys. It doesn't say intercept, but if you look at that y coordinate at this point in my lower right-hand corner, it's scientific notation to the -12th power. So 0.201 is one of the solutions here. So I'm going to write this out. Y equals 0.201. Maybe the trace isn't working as well as I want it to, so maybe I should go back to Analyze Graph and try to find a 0 of this function, and my lower bound would maybe be, I'm looking at my, oh boy, I'm looking at my second intercept now, so my lower bound might be right here, my upper bound might be right over there. Okay, 2.940 looks like a second solution. Y equals 2.940. Okay, a third one now. Let's do that same trick again, everybody. Let's find a 0. And now I'm looking at this third intersection right here. So my lower bound would be about there, my upper bound about there, 6.485 if we were to round that. Okay, and then it looked like there was one more that we were going to be able to come up with here. So one more time. Let's do a 0 yet again. Lower bound over here. Upper bound past that, 9.223. Okay, so that is what we've come up with here, 9.223. Great work to get to this point. There's only one problem. The solution that they have written out there, guys, only has 3 answers and not 4. And at first, I was as confused about that as anybody else. Then I looked at what wasn't there, and I realized what was going on. The second solution that we came up with, y is equal to 2.940, is not present in their list. They have this first solution, this third solution, and this fourth solution, but not this one. And I wondered why that was. So look at that value, guys, y equals 2.940, and then let's go back and look at this graph. 2.940 is just a little bit less than 3. Oh, this is just mean. And now I realize this value, 2.940, is not in the range of this function. This graph doesn't exist when y is equal to that value right there of 2.940. My guess would be if you put that number in here, you'd end up with a negative number on that right-hand side. And if x squared was something negative, let me just make up something like -5, you would go to take the square root of that, and you'd end up with an imaginary solution, and we don't do imaginary solutions in AP Calc, everybody. So like I said, this was already a hard problem, and they made it extra mean by giving you a solution then that you had to throw out because it doesn't exist in the range of y values for this function. So if you got those 4 answers, you did a really good job and pat yourself on the back. But if a problem like this ever were to show up again, you've got to make sure that the solutions you come with are actually in the domain of the function, if they're x values, or the range of the function, if they're y values. Okay, lesson learned, I guess. All right, and on to C. This was an oddly worded question and not really like one that we've seen very much. We're supposed to find the average value. Now, right then, you might hopefully say, oh, okay, I know a formula for average value. But now let's take a look. Average value of the x-coordinates of the points on the graph in the first quadrant between y equals 5 and y equals 9. Okay, what I'm hoping you guys know is that the average value formula we've been dealing with just the second semester is 1 over b minus a multiplied by the definite integral from a to b of whatever function it is you're trying to find the average value of, which is usually f of x measured with respect to x. That's the formula we're going to use here, but we're trying to find the average value of your x-coordinates. And a function here is usually solved for y, meaning that all the values of this function get you your y-coordinates. They want us to flip this one around. So let's remember that the original equation here was x squared is equal to, I had it and then I lost it, x squared, there it is equal to a -2 plus y and then a plus 5 cosine of y. What we now need to do, guys, is solve this equation for x. So a square root of the left and a square root of the right. So x, there's nothing you can do to simplify this disaster. X is the square root of -2 plus y plus 5 cosine of y. That is what we're going to put right here. So our average value is going to be, and what's going on here, guys? A definite integral of, we're solving for x right now, so it's going to be the square root of -2 plus y plus 5 cosine of y. Since our integrand is written in terms of y, that should tell you that the variable of integration here is going to be dy. That should tell you that the limits of integration here and here need to be the lowest and highest values of y in this range, which they've told us are 5 and 9. So I'm going to cram a 5 right there and a 9 right there. And now that tells me that out in front of this, we're taking 1 over, and that's a 9 minus 5. And this should give us the average value of all of our x-coordinates. So there's a lot going on in this problem here, guys. How do I get back here? There we go, there we go. And let's type this in, guys. We've got a fraction with 1 over, and that's a 9 minus 5 right there for our denominator, which gets multiplied now by a definite integral. So menu 43 for you guys, an integral that starts at 5 and goes up until 9, and the integrand, we said, was going to be the square root of -2 plus y, let's get that right, gotcha, -2 plus y plus 5 times the cosine of y. And we're integrating all of that with respect to y. And when we hit enter, I would go ahead and hit control enter just to get that decimal. This should be the answer we're looking for here, guys, of 2.550. So let's write that one down. 2.550 is going to get us the average value here. So We didn't do great on number 2, and I'm not entirely shocked by that, and I'm not terribly disappointed in that, because number 2 here is kind of an unusual problem. It was a weird presentation. They asked you some weird questions. They set a trap for you by making you think that that y value was 5, and by the way, if you didn't have that right, the rest of this got to be a little bit difficult as well. So a lot of weird things going on here in number 2, but hopefully it makes some sense now that we've talked about it, and if we do see any problems like this again in the future, we'll have a better sense for how to handle them moving forward.